October 2025, NASA's Parker Solar Probe and ESA's Solar Orbiter are both deep within the Sun's outer atmosphere when they detect something no one can explain. A distortion in the solar wind that shouldn't exist. Plasma streams that normally travel in smooth, predictable flows suddenly bend, ripple, and realign as if pulled by an invisible magnetic tide. The point of origin, triangulated across both instruments, converges on a single source, 3I Atlas. For weeks, scientists have watched the interstellar object glide through the inner solar system, tracking its trajectory, its albedo, its faint ion trail. But this is different. The data suggests that the solar wind isn't merely reacting to its presence. It's being shaped by it. The curvature is symmetrical, the deflection measurable, and the pattern sustained as though something around 3I Atlas is pushing back against the Sun itself. At first, it was dismissed as a sensor glitch, a magnetic storm, or a data processing anomaly. Yet the same pattern appeared again, this time confirmed by a third observer, NASA's Solar Dynamics Observatory. Hours later, SOHO's coronagraph captured what looked like a filament of plasma diverting around the object's projected path. By the time the James Webb Space Telescope joined in, a clearer picture had emerged. Sunlight itself was flickering off 3I Atlas, modulated in a rhythm too structured to ignore. What we're seeing now challenges every known model of how plasma interacts with inert matter in solar proximity. Something is bending the wind, something that might be more than gravity, more than mass. And in the next few minutes, we'll uncover what could be one of the most important findings of this century. But first, we need to understand how the distortion began. The first irregularities appeared in late September. Parker Solar Probe, orbiting just 8.5 million kilometers from the Sun, recorded a faint but measurable lateral drift in the solar wind. A deviation of less than 0.02 degrees at first, barely perceptible against the background noise. But within 48 hours, the angle doubled, then tripled. The plasma flow, once steady, began curling around an unseen point more than 90 million kilometers away, precisely where 3I Atlas had been projected to pass. By October 3rd, the Solar Orbiter confirmed the anomaly independently. Its magnetometers picked up coherent shifts in the interplanetary magnetic field, synchronized across multiple axes, with phase alignment pointing directly toward the object's trajectory. The implication was unsettling. Whatever 3I Atlas was, it appeared to be interacting with the solar environment, not passively, but actively, as if encased in an electromagnetic field powerful enough to reroute charge particles streaming from the Sun at hundreds of kilometers. At the Johns Hopkins Applied Physics Lab, mission analysts ran simulations to test for natural causes. None fit. Even a dense metallic core or ionized outgassing couldn't sustain that level of deflection symmetry over such a wide spatial range. Solar flares too random, magnetic reconnection events too localized, dust tails or radiation pressure orders of magnitude too weak. What Parker observed wasn't turbulence, it was structure. The data packets released on October 5th showed a distinct waveform, plasma density oscillations forming a repeating pattern every 240 seconds. That timing was critical. It aligned almost perfectly with the rotational period inferred from 3I Atlas's earlier brightness variations. If confirmed, it would mean the solar wind was somehow responding to the object's rotation, like a fluid dancing to a metronome set in deep space. When the research team plotted the plasma deviation vectors in 3D, the results stunned them. A bow-shaped arc extending nearly 30,000 kilometers ahead of the object, tapering along its sides. The hallmark of a magnetic obstacle, a mini-magnetosphere, one scientist called it in a closed briefing. Except this one wasn't following the physics of any known planetary field. It didn't diffuse. It maintained coherence, holding its curvature over several million kilometers as the probes continued recording. The most compelling part came from timing correlation. The anomaly propagated outward at nearly the same velocity as the solar wind itself, 450 km/s, suggesting an interaction boundary, not an emission. In other words, 3I Atlas wasn't releasing plasma. It was shaping the plasma already there. But shaping requires force, and force requires energy. So where would that energy come from? A small but growing number of researchers now suspect that 3I Atlas isn't just an inert traveler, but an active system, one that may be harnessing or redirecting the sun's charged output. The Parker probe's magnetometer registered transient reversals, momentary flips in field polarity lasting fractions of a second, arranged in sequences too rhythmic to be random. To the naked eye, these look like flickers, but to physicists, they suggest resonance, feedback between two magnetic domains, interacting in a closed loop. Here's where the numbers start to challenge belief. The calculated magnetic moment implied by the deviation exceeds 10 to the power of 9 Tesla, a magnitude comparable not to a comet or asteroid, but to small-scale stellar phenomena. No comet nucleus, no metallic core, no dust envelope could reach that. The only scenarios that match involve either a self-sustaining plasma shell or something deliberately engineered to act like one. Still, most official statements remain cautious. ESA issued a brief note, calling the readings unusual, but likely transient, while NASA's Heliophysics division described them as non-gravitational plasma interactions of undetermined origin. Yet internally leaked correspondences reveal deeper concern. If these deflections persist, they could alter solar wind models for the entire inner heliosphere. And if 3I Atlas continues to behave as observed, it might become the first verified case of a naturally or artificially controlled interaction between an interstellar object and the Sun. At this stage, there's no proof of control, only correlation. But in science, correlation repeated across independent instruments is where revolutions begin. And as more data arrives, one fact grows impossible to ignore. The deviation is not random, it's rhythmic, patterned, coherent. Something inside that stream of solar particles is responding, and it's doing so with precision. Next, we look closer at what that precision reveals. Once the deviation was confirmed, scientists turned their focus to what came next, the pattern. Because random chaos doesn't repeat itself with such precision. And yet, that's exactly what 3I Atlas seemed to be doing, repeating. The solar orbiter's SWAP instrument began transmitting streams of plasma density data that, when visualized, revealed something extraordinary. The fluctuations weren't noise. They formed harmonic intervals rising and falling with machine-like regularity. Every 240 seconds, the same interval observed in Parker's earlier data. The density would spike, peak, and settle back into equilibrium, as if the solar wind itself were oscillating to a beat. At first, the pattern was faint. Then, as 3I Atlas drifted closer to perihelion, the signal strengthened. What had looked like a distant anomaly now resolved into distinct wave fronts, radiating symmetrically outward. Each crest mirrored the next, aligned with the object's trajectory, as if its movement through space was orchestrating the plasma around it. In a late-night session at the European Space Operations Center, engineers overlaid the plasma wave data with the light curve readings from the James Webb Space Telescope. The match was near perfect. Every modulation in brightness coincided with a corresponding rise in plasma density, light and matter moving together in sync. Whatever 3I Atlas was doing it with coherence across multiple energy domains. To heliophysicists, this coherence was the key anomaly. Natural plasma turbulence tends toward disorder, eddies, vortices, sudden reconnections, never precision. But the frequencies near 3I Atlas held within 0.02 Hz, holding steady for days at a time. The Sun's own magnetic turbulence should have disrupted that signal almost immediately. It didn't. When the data was passed through Fourier spectral analysis, a second pattern emerged, a subharmonic sequence buried beneath the main oscillation. Every fifth wave carried a slightly higher amplitude, as if encoding a secondary rhythm. Analysts referred to it as the heartbeat signal. To some, it was evidence of a natural resonance forming between the solar wind and an object with an unusually conductive surface. To others, it looked like control, as though the object were adjusting itself dynamically in response to external pressure. A confidential internal memo from the Solar and Heliospheric Physics Division, later leaked to the public, described the phenomenon in cautious terms. Observed coherent periodicity cannot be accounted for by spontaneous magnetohydrodynamic processes. External field structuring suspected. In simpler terms, something external was shaping the pattern. The data alignment grew stronger as 3I Atlas passed 0.72 astronomical units. Both Parker and Solar Orbiter observed secondary wave fronts forming perpendicular to the main plasma flow, creating what appeared to be standing waves, fixed regions of constructive and destructive interference. The geometry of these structures resembled laboratory plasma confinement experiments on a scale hundreds of millions of times larger. The implications were staggering. If the standing waves were self-sustained, they could represent a feedback mechanism, a way to maintain stability amid the solar wind's chaos. In plasma physics, that kind of stability requires precise tuning between the field source and the surrounding charge medium. Planets don't do that. Comets don't do that. Machines might. Still, the debate split the scientific community. Some pointed to analogues in magneto-tail reconnection events around Jupiter's moons, complex yet still natural magnetic interactions. Others warned that such comparisons were stretched thin. Jupiter's magnetosphere is planet-sized. 3I Atlas is barely a few kilometers across. To achieve the same coherence, its field would need to be impossibly strong or impossibly efficient. Meanwhile, the light modulation continued. JWST's near-infrared readings showed subtle but consistent dips in reflected intensity at regular intervals. Not random flickering, but frequency-specific dimming. The intervals matched the plasma wave harmonics almost exactly. Light and plasma were resonating together, a coupled system locked in sync. If this were a coincidence, it was one that defied probability. By the time the data reached the Space Weather Prediction Center, analysts began mapping potential models. One hypothesis suggested a superconductive layer within 3I Atlas's crust, capable of sustaining persistent currents that generate stable magnetic fields. Another, far more controversial, proposed a plasma sheath maintained by controlled electron flow, effectively forming an artificial magnetic cocoon. It was speculation, but grounded in math. If such a sheath existed, it would not only explain the symmetry and coherence, it would also make 3I Atlas the first known object capable of dynamically shaping solar plasma for stability or propulsion. The final report from the early phase concluded with a single line that no one could quite agree on how to interpret. Observed periodicity consistent with engineered resonance or undiscovered plasma self-organization regime. Either way, the universe had just added a new category to its vocabulary, one we didn't yet understand. But the story doesn't stop with patterns, because the next anomaly wasn't just in the plasma, it was in the light itself. The shift began subtly, just faint flickers recorded in the near-infrared bands. But by early October, the pattern was undeniable. The James Webb Space Telescope, positioned nearly 1 million miles from Earth at L2, captured periodic fluctuations in the sunlight reflected from 3I Atlas. They weren't random. They occurred every 240 seconds, perfectly matching the plasma resonance cycle already detected by Parker and Solar Orbiter. At first, the team at the Space Telescope Science Institute assumed a calibration error. Webb's photometers are so sensitive that even micrometeorite strikes can distort readings. but system checks came back clean. The modulation persisted through multiple instruments, across multiple filters, and even during attitude adjustments. It wasn't a glitch, it was a signal. Each pulse of light rose and fell in amplitude with extraordinary consistency, a modulation depth of roughly 0.04%, far too structured to be a reflection artifact. When plotted over time, the waveform displayed harmonic layering, a frequency envelope similar to those used in radio communications. Only here, the transmitter was an interstellar object drifting through the solar wind. The spectral signature deepened the mystery. Normally, sunlight reflected from dust or rock yields smooth curves, neutral albedo across visible bands, declining into the infrared, but 3i Atlas broke that rule. Its reflection spectrum showed narrow absorption notches, distinct dips at 1.06 and 1.55 micrometers, regions associated with metallic interference and photonic scattering. To physicists, those were telltale signs of structured surfaces, possibly layered, possibly reflective, under electromagnetic control. Then came the alignment data. When the object rotated, as measured by faint brightness oscillations every 4 minutes, the modulations synchronized as though light and rotation were phase-locked. It behaved like a spinning mirror, adjusting its reflectivity and rhythm with its spin. That degree of coherence shouldn't exist in natural outgassing or albedo changes. Comets scatter light chaotically. Asteroids flicker irregularly. This was neither. The Webb team forwarded their findings to the Solar and Heliospheric Observatory for cross-confirmation. SOHO's LASCO instrument, operating in the visible range, captured matching luminosity fluctuations at the same intervals. Even accounting for observational lag, the phase correlation exceeded 97%. That meant one thing: the modulation was real and consistent across multiple vantage points and wavelengths. Some analysts speculated that 3i Atlas might possess a reflective crystalline structure, perhaps a surface of layered silicates acting as a natural diffraction grating. But that explanation quickly faltered when the frequency precision was measured. The timing drift over 10 days was less than 1/10 of a second. Nature rarely maintains precision like that over millions of kilometers and constantly shifting solar pressure. Others began asking harder questions. What if the object wasn't merely reflecting sunlight, but manipulating it? What if the same electromagnetic field bending the solar wind was also influencing photons, redirecting them, perhaps even modulating them deliberately? To test that possibility, a combined analysis between Webb's NISPEC and ESA's Solar Orbiter X-ray telescope was initiated. If the light modulation were electromagnetic in origin, correlated X-ray fluctuations might appear as secondary harmonics. They did. Minute synchronized spikes in X-ray intensity trailed the light pulses by approximately 0.6 seconds, consistent with the propagation delay of solar plasma response across a controlled magnetic boundary. In other words, 3i Atlas was behaving as if it possessed an active electromagnetic envelope, one capable of interacting with both matter and light. Skeptics countered swiftly. They proposed phase-locked scattering, a theoretical process where solar wind interactions could momentarily align dust particles into transient reflective planes, creating quasi-periodic flashes. But even that model broke down under the data's consistency. For such alignment to persist over weeks, the structure would have to be self-maintaining, again implying a stabilizing field. By mid-October, a new term began circulating quietly within heliophysics circles: artificial albedo modulation. No one would say it publicly, but privately, researchers exchanged encrypted notes and model plots that pointed toward one extraordinary idea: that 3i Atlas might be demonstrating some form of directed energy control, converting electromagnetic flux into structured reflection. To engineers familiar with plasma dynamics, that hinted at more than shielding. It suggested intent, or at least design. A self-tuning magnetic surface could redirect solar photons for propulsion, orientation, or energy regulation. In essence, it could use sunlight itself as both power and steering mechanism. If so, this was no passive rock from another star system. It was a system responding to its environment in real time, as if maintaining equilibrium, as if alive with mechanism. But light and plasma aren't the full story. Something else was beginning to appear in the data: rhythmic pulses, not just in brightness or density, but in charged particle acceleration itself. And that led scientists to the next, even stranger revelation. By mid-October, it was no longer a question of whether 3I Atlas was influencing the solar wind. The question had become how what could possibly generate a magnetic field strong enough to deflect plasma streams at such distance and with such symmetry. The first hints came from Parker Solar Probe's Fields instrument, which captured a sequence of magnetometer spikes during its 17th perihelion pass. Normally, as the probe skims through the solar corona, it records chaotic fluctuations, the natural turbulence of charged particles dancing through the sun's magnetic maze. But this time, the readings were different. The spikes weren't random. They formed a mirrored waveform. When plotted over time, the field reversals aligned along a sinusoidal pattern that corresponded to 3I Atlas's position relative to the solar ecliptic. Researchers at NASA's Goddard Space Flight Center fed the data into magnetohydrodynamic (MHD) simulations. The results were staggering. The only configuration that reproduced Parker's measurements required a large-scale magnetic envelope, a coherent bubble extending tens of thousands of kilometers around the object, with field lines bowing outward like a shield. Such a formation typically exists only around planets with molten iron cores or around spacecraft equipped with magnetic deflection systems, neither of which should apply here. If this field were natural, its origin would have to lie in either rapid internal rotation of conductive material or an external current loop sustained by interaction with the solar wind itself. But both explanations faced problems. For rotation to sustain a magnetosphere, 3I Atlas would need a dense metallic core, spinning faster than any known comet nucleus. Implausible, given its small size and observed stability. And for an external current to form spontaneously, the solar plasma would have to maintain perfect alignment for days. An event so improbable that no model could replicate it. Then came the comparative data. Solar Orbiter's MAG instrument recorded the same field topology, identical polarity, identical strength from a different vantage point. The coherence across distances of millions of kilometers ruled out local effects. Something was holding the field together, something powerful enough to resist the solar wind's erosive pressure. At its estimated strength, the magnetic flux density around 3I Atlas measured close to 20 microteslas. Not extraordinary in isolation, but remarkable in stability and symmetry. For context, Earth's magnetic field at the surface fluctuates around 30 to 60 microteslas, yet it's generated by a rotating planetary dynamo. For an interstellar fragment only a few kilometers wide to sustain nearly comparable field strength with no evident energy source defied every known rule. Heliophysicists began to describe it as a static envelope, a kind of artificial magnetosphere. It moved with the object maintaining shape and polarity, despite the shifting solar wind pressure. When the sun's magnetic sector boundary passed, a zone where the solar magnetic polarity flips, 3I Atlas's field didn't react chaotically. It compensated. The bow shock adjusted angle, preserving balance as though guided by feedback control. This was the moment the narrative began to shift, because such feedback implied responsiveness. A system capable of sensing and adapting to external conditions. One astrophysicist, speaking off record, compared it to a spacecraft using the sun's own wind as both power source and stabilizer. The data's implications rippled outward. If 3I Atlas truly possessed a coherent magnetosphere, it would mean the object could survive far closer to the sun than any known natural body of similar size. It could also mean that it was using electromagnetic principles not for defense, but for propulsion, redirecting the solar wind as thrust. A paper circulated internally at ESA explored this possibility, citing a decades-old theoretical concept known as a magnetic sail. In this design, a superconducting loop creates a magnetic field that deflects charged particles, generating momentum without fuel. The math worked, and eerily, it matched the observed plasma deflection patterns. Still, the mainstream community urged restraint without direct imagery or in situ measurement. Claims of artificial magnetism remain speculative, yet the consistency of the data, plasma deviation, light modulation, and now magnetic coherence painted a picture that natural explanations were struggling to account for. Then came the final clue. When Parker crossed a region trailing the anomaly's wake, it detected faint streams of accelerated protons, not emitted from the sun, but seemingly reflected. The magnetic boundary surrounding 3I Atlas was not absorbing solar particles. It was redirecting them backward, creating a tail of reversed flow, something only an organized field could accomplish. This was more than shielding, it was structure, and structure implied purpose. If this magnetosphere wasn't a passive effect, then something or someone had engineered a way to manipulate one of the most violent environments in the solar system with elegance and control. But the question now was, to what end? To answer that, researchers turned to the particle data, where they found something even stranger. Not just deflection, but resonance. It began with a pattern that shouldn't exist in space. A repeating pulse in the velocity of charged particles measured simultaneously by SOHO and NASA's Solar Dynamics Observatory. Every few minutes, both spacecraft recorded synchronized spikes in proton energy, each rising and falling in perfect sequence, each wave aligned with 3I Atlas's orbital path. At first glance, it looked like interference. But when the timestamps were matched to the light and plasma data from earlier in the month, the alignment was exact. The same 240-second rhythm, the same phase precision, now visible not just in plasma flow or reflected light, but in particle acceleration itself. It was as if every 4 minutes an invisible switch flipped somewhere near the object, releasing a brief burst of energy into the solar wind. The heliophysics team at NASA's Goddard Space Flight Center ran comparative simulations using standard solar wind models. None could reproduce the resonance. The sun's magnetic field fluctuates continuously, but not periodically. To generate a stable harmonic, you'd need a structure that traps charged particles, a resonant cavity. In planetary terms, that's the space between a magnetosphere and the surrounding plasma where energy waves can bounce and amplify. But for something the size of 3I Atlas, such coherence would be nearly impossible unless the field was not just magnetic but finely tuned. When the data was filtered for frequency, the resonance stood out sharply. A carrier tone at 0.042 Hz with distinct side bands, exactly the kind of modulation one might expect from an oscillating magnetic boundary interacting with solar plasma. That interaction was too consistent to be random turbulence. It behaved like resonance under active control. The implications reached beyond magnetism. When the rhythmic pulses were converted into power spectra, scientists found something stunning. The harmonic ratios match those of known cyclotron resonance frequencies for protons in a magnetic field of approximately 20 microteslas, the same field strength estimated for the magnetic envelope around 3I Atlas. That precision left little room for coincidence. The object appeared to be tuning its environment, or at least existing in a state of sustained resonance with it. To put that in perspective, on Earth, creating cyclotron resonance requires immense laboratory equipment, coils, power sources, vacuum chambers. Yet here in open space, an interstellar body was doing it naturally or deliberately by coupling to the sun's magnetic field. The effect wasn't localized either. SOHO recorded standing plasma waves extending millions of kilometers downstream, echoing like ripples through the heliospheric current sheet. The sun's plasma environment was literally singing in resonance with 3I Atlas, a cosmic chord repeating every 4 minutes with unbroken stability. This phenomenon, coherent energy exchange between a magnetic field and charged particles, is known in advanced plasma physics as induced resonance amplification. It's theorized for potential propulsion systems, devices that extract kinetic energy from solar plasma without physical contact. The principle is simple. In theory, redirect the energy already present in the solar wind using synchronized magnetic oscillations. But in practice, it's nearly impossible to stabilize. And yet, 3I Atlas seemed to be doing exactly that. The most conservative explanation proposed a natural feedback loop, perhaps ionized outgassing interacting with magnetic field lines to create self-oscillation, but that would require consistent gas emission, and spectral analysis showed none. The object wasn't venting. It was silent, stable, metallic in reflectivity, inert in emission, yet resonant in effect. The more radical interpretation emerged in a joint internal memo between ESA and NASA physicists. Evidence suggests 3I Atlas may be exhibiting controlled plasma resonance consistent with theoretical models of electromagnetic energy extraction. That phrase, energy extraction, changed the tone of the entire investigation, because if 3I Atlas was drawing energy from the solar wind even passively, it meant the object was participating in an active exchange of power with its environment, and that would make it the first known interstellar system, natural or artificial, to operate on stellar energy directly. The energy values implied by the data were small by stellar standards, on the order of gigawatts. But the efficiency was astronomical. A gigawatt-scale exchange occurring naturally from plasma resonance would require nearly perfect tuning between magnetic field geometry and particle flow. That kind of perfection simply doesn't happen by accident. Still, the scientific community hesitated. No one wanted to suggest that the object was doing something intentionally. Yet every model built to explain the resonance ended up looking less like geology and more like engineering. As more data arrived, the harmonic pattern began to shift slightly, tightening in frequency as 3I Atlas approached the inner orbit of Mercury. It was adapting, matching the changing density of the solar wind like a signal recalibrating in real time. That raised a new question. If the resonance wasn't just a byproduct, what was its purpose? Some theorized it was stabilization, maintaining magnetic equilibrium under solar pressure. Others whispered something more audacious: propulsion, the possibility that 3I Atlas was using plasma resonance not just to survive the sun, but to harvest its energy for movement. That idea was dismissed publicly, but internally it became impossible to ignore, because the next datasets didn't just show resonance, they showed acceleration. By mid-October, a quiet consensus had formed behind closed doors. 3I Atlas wasn't simply enduring the solar wind, it was using it. The data from SOHO and Parker Solar Probe hinted at a mechanism that looked suspiciously like energy conversion. It wasn't theoretical anymore. Something measurable was happening in the plasma surrounding the object, something that mirrored the basic principles of power generation. The first sign came from Parker's sweep instrument, which measures electron temperature and particle flux. Near the region aligned with 3I Atlas's path, Parker detected a drop in electron temperature of roughly 1.8%. That might sound insignificant, But in the dense streams near the sun, such a decrease meant billions of joules of thermal energy had vanished, siphoned off, or redirected somewhere else, and the timing matched the resonance window perfectly. To test for correlation, analysts overlaid these readings with magnetic field data. The loss of thermal energy coincided with a sharp spike in magnetic tension the very moment the resonance amplitude peaked. In energy terms, it looked like a transaction: plasma energy disappearing, magnetic field strength increasing, a near-perfect signature of electromagnetic coupling. If true, 3I Atlas was doing something once confined to theory, extracting kinetic energy from the charged particles of the solar wind. It would mark the first naturally observed case of what physicists call magnetohydrodynamic harvesting. A process once imagined for futuristic propulsion systems capable of sailing through plasma instead of air or vacuum. But this was no lab experiment. It was happening in the corona of the sun. The energy calculations were almost surreal. The localized magnetic stress multiplied by field area suggested a power flow on the order of 5x 10^9W, 5 GWs concentrated within a field structure only a few dozen kilometers wide. For comparison, that's roughly the output of an entire terrestrial power plant, condensed into a region the size of a mountain. And it was repeating rhythmically every 4 minutes, like an engine running on a cosmic cycle. At ESA's Space Science Data Center, a special task group was formed under quiet urgency to model the effect. Their first working theory proposed that 3I Atlas was surrounded by a conductive shell or sheath acting as a plasma resonator. In this model, solar particles flowing through the magnetic boundary would induce circulating currents, storing energy in the object's electromagnetic field and releasing it in pulses. The cycle would maintain itself indefinitely, drawing power directly from the sun's own outflow. That explanation was elegant. It also blurred the line between physics and engineering, because such a system, self-sustaining, energy-positive and perfectly tuned to its environment, would effectively function as a stellar generator. And if the process could be directed, it could also serve as propulsion by expelling modulated plasma or redirecting charged particles. 3I Atlas could, in theory, produce thrust, silent, continuous, and powered by the sun itself. Not everyone accepted that idea. Critics argued that the apparent energy deficit might be illusory, caused by local field compression or unmodeled plasma interference. But those objections weakened as more instruments confirmed the pattern. The solar orbiter's energetic particle detector recorded subtle periodic bursts of high-energy ions, leaving the object's wake, energy output, not absorption. What troubled researchers wasn't just the possibility of harvesting, but the precision. The phase-locked synchronization across light, plasma, and field data suggested a feedback loop operating with millisecond accuracy. Natural bodies can resonate, they cannot calibrate yet. 3I Atlas's field geometry was adjusting dynamically to variations in solar density, keeping the system perfectly balanced. Too perfect, some argued, to be chance. That led to whispers in scientific forums rarely spoken aloud. If 3I Atlas was truly engaging in electromagnetic coupling, it could represent technology on a scale humanity barely understands. The manipulation of stellar energy at will. Freeman Dyson once theorized civilizations might surround their stars to capture their power. What if instead they sent smaller machines, emissaries, capable of harvesting directly from the wind itself? The comparison was irresistible. A Dyson construct collects radiation, a magnetoplasma construct collects motion. Both achieve the same end: energy drawn from the heart of a star. Still, the official report stayed cautious. The European Space Agency labeled the event a magnetohydrodynamic anomaly of unknown origin, NASA used the term non-gravitational acceleration signatures pending verification, but privately many admitted the truth. They had never seen anything like it. As 3I Atlas continued its inward drift toward perihelion, its modulation frequency began to shift again, compressing slightly as though compensating for the increasing solar wind velocity. If the object was drawing power, the next phase would be amplification. The closer it came to the sun, the more energy would be available to tap. And that realization brought a new question, one that changed the mood of every control room tracking the event. If the energy was building, where would it go next? By the time 3I Atlas crossed inside Venus's orbit, the data had become almost impossible to reconcile with natural models. Every new transmission from the Parker Solar Probe added to a picture that seemed less like a comet and more like a controlled reactor moving through plasma. The object's electromagnetic signature had grown stronger, not linearly, but exponentially. Magnetometer readings indicated a magnetic moment on the order of 1.1 x 10^9 Tesla. That number alone triggered disbelief. For context, Earth's own dipole moment is roughly 8 x 10^22 ampm2, generated by a liquid iron core 12,000 kilometers across, scaled to 3I Atlas's estimated 4-kilometer diameter. The field intensity implied a density and energy concentration so extreme that no known material, not iron, not nickel, not even superconducting alloys under laboratory conditions, could sustain it without vaporizing. Physicists began referring to this discrepancy as the scale problem. If the field was real, its source couldn't be internal. It had to come from interaction. A field induced, not generated, but induced by what? The first possibility was geometric resonance, the idea that 3I Atlas, a structure somehow captured and magnified magnetic flux lines the way a tuning fork amplifies sound. In this model, the object's shape might be crucial, perhaps elongated, perhaps ringed, acting as a resonant coil. But radar echoes from the deep space network gave no clarity. The object's radar cross-section fluctuated wildly, sometimes reflecting like a smooth sphere, sometimes scattering like a jagged shard, as though its surface wasn't solid, but layered or adaptive. Then came the energy density calculations. At 10^9 Tesla, the field energy around the object would equal roughly 3 x 10^17 joules, equivalent to the total electrical consumption of Earth for an entire day, confined within a magnetic sheath a few dozen kilometers wide. No natural dynamo, no rotating nucleus could generate that. And yet the field wasn't chaotic. It was coherent, stable, pulsing rhythmically with each 4-minute cycle. At NASA, researchers began modeling an alternative explanation. What if the field wasn't produced by magnetism alone, but by a deeper coupling between electromagnetic and space-time curvature? The idea sounded speculative, almost heretical, but the math fit. A sufficiently strong oscillating electromagnetic field could in theory induce minute distortions in local space-time, amplifying its own strength through feedback, a loop between gravity and magnetism. In the equations, that feedback produced values eerily close to what Parker was observing. Of course, that raised a disturbing implication. If 3I Atlas were engaging in space-time assisted field amplification, it wasn't just bending plasma, it was bending the fabric through which plasma moves. The discussion split sharply between camps. The conservative group insisted on hidden natural processes, unknown superconductive minerals perhaps, or induced currents in trapped solar plasma forming temporary field shells. The other camp, smaller, quieter, but growing, proposed that the field coherence and precision were signatures of controlled energy manipulation. One internal note leaked from ESA's heliophysics division contained a single line that rippled through online forums when it surfaced. Observed parameters inconsistent with any passive interaction, indicative of active field regulation. The word active changed everything. If regulation was occurring, It implied feedback, sensors, circuits, intelligence, or at least algorithmic control. Something maintaining equilibrium intentionally. The next problem was distance. The field's influence extended far beyond the expected boundary, up to 2 million kilometers, according to particle telemetry. A single object influencing solar plasma at that scale should have shed enormous amounts of energy. But instead, 3I Atlas appeared to be conserving it, almost as if rerouting excess charge through invisible pathways. That's when Parker detected something even more puzzling. Within the magnetic envelope, solar wind velocity dropped nearly to zero. The plasma wasn't just deflected. It was stilled, a void, a calm pocket carved into chaos. Engineers compared it to the eye of a storm, or the wake behind a ship moving through water. If a 4-kilometer object could carve a stable zero-flow region in a supersonic plasma stream, it meant that the laws of hydrodynamics, magnetism, and thermal equilibrium were all being rewritten in real time. And the only analogues for that kind of precision came not from astronomy, but from fusion research. Tokamaks, stellarators, plasma containment rings, human attempts to do exactly this on miniature scales. Except here, it was happening naturally, or by design in open space at solar proximity. The silence from official agencies was telling. Updates slowed. Data uploads from Parker were delayed by days. Public dashboards went quiet without explanation. Some suspected routine filtering, others sensed unease, a quiet attempt to study before speaking. In private, one senior plasma physicist summarized the problem bluntly. Either we're watching the most sophisticated electromagnetic interaction nature has ever produced, or we're looking at evidence of engineering far beyond our comprehension. And yet, the anomalies continued to compound. Because as 3I Atlas's field expanded, it began to affect not just the solar wind, but the trajectories of nearby dust and charged microparticles. Small debris streams started to orbit around it, tracing invisible curves as though locked within its magnetic geometry. Something was organizing matter on a microscopic level. And if that was true, then what came next? The counter-arguments would either rescue science from speculation or push it over the edge. As the data mounted, so did the discomfort. Within NASA, ESA, and the Royal Astronomical Society, the tone of official communication began to shift from wonder to caution. Words like structure and field control quietly disappeared from press releases, replaced with phrases such as transient plasma dynamics and localized instabilities. Behind closed doors, though, even the most conservative scientists knew they were in uncharted territory. The first major rebuttal came from a joint working group on heliophysics convened in Geneva. Their conclusion, the coherent anomalies might not be evidence of intelligence at all, but an extremely rare form of plasmoid resonance, a self-organizing behavior observed in magnetized plasma streams. Under certain conditions, they argued charged particles can spontaneously align and create nested magnetic shells, temporarily mimicking the structure of an artificial field. In theory, that explanation fit. The sun's magnetic field is chaotic enough to produce short-lived resonant bubbles, but there was a problem: scale and stability. Those natural plasmoids last seconds, minutes at best. 3I Atlas's envelope had remained stable for weeks. Others turned to magnetic reconnection, a process where tangled field lines snap and realign, releasing bursts of energy that can accelerate particles and create transient boundaries. Perhaps they suggested 3I Atlas had wandered into such a region. A coincidence of timing and trajectory that made it look like the cause rather than the passenger. Yet the reconnection hypothesis faltered under close analysis. Reconnection events are chaotic and short-range. Their geometry shifts constantly. The field around 3I Atlas, in contrast, was fixed and symmetrical, its axis locked to the object's own rotation, not the sun's field lines. The third explanation, and perhaps the most imaginative within the bounds of physics, came from a group at Kyoto University. They proposed a previously unknown state of matter, a superconductive plasma lattice formed under extreme solar radiation. In this model, layers of charged dust and ions might align to create transient conductive bands, generating induced magnetic fields without any solid structure. Essentially, the sun itself could be weaving a natural magnetic skin around the object as it moved through its wind. The idea was elegant and even romantic in its way, the cosmos creating its own symmetry by accident. But when the team ran the numbers, the required ion density exceeded what the solar wind could provide by a factor of 10,000. Even if the lattice formed, it would collapse within minutes. Meanwhile, public speculation was spiraling. Online forums, astronomy boards, and independent researchers began drawing parallels between 3I Atlas and past anomalies. Oumuamua's non-gravitational acceleration, the Ulysses probe's unexplained magnetic flips, even whispers of solar sail propulsion experiments long buried in classified archives. The agency's silence only fueled the fire. Still, some scientists refused to cross the line into speculation. One particularly cautious astrophysicist, Dr. Helen Griggs from the European Southern Observatory, summarized her position simply: "We don't need aliens to explain what we don't yet understand. The sun is a laboratory of extremes. We've barely begun to map its language." Her statement gained traction, echoed by dozens of papers arguing that the 3I Atlas anomaly might reveal an undiscovered branch of plasma physics rather than evidence of design. They called it electromagnetic self-ordering, the capacity of plasma to form coherent structures spontaneously, much like crystals form from chaos in the right conditions. Yet even within that cautious framework, one fact refused to fit the periodicity. Nature, as chaotic as it is, doesn't keep time like a metronome, and 3I Atlas was keeping time down to fractions of a second across instruments separated by millions of kilometers. A leaked internal correspondence from ESA's solar and heliospheric division captured the quiet frustration. We are running out of natural analogues. Every model we build to explain this using known processes collapses under the precision of the data. Still, the agencies held their line. The official position remained that the anomalies were non-deterministic, yet statistically consistent with natural behavior. The language was dense, cautious, a hedge against admitting how strange things truly looked. But away from the committees and press conferences, a smaller circle of researchers began to ask a bolder question. What if the counter-arguments weren't wrong, just incomplete? Maybe the physics was real. Maybe it was plasma self-organization, resonance, and magneto-hydrodynamic balance, but not random. Maybe 3I Atlas wasn't fighting the laws of nature at all. Maybe it was using them, and that realization that the anomalies might represent not defiance of physics, but mastery of it, opened a door many scientists had tried to keep shut. Because if the coherence, symmetry, and energy transfer weren't accidental, they might be evidence of intention. By the third week of October, a quiet fracture had formed within the scientific community. On one side stood the cautious empiricists, those still committed to finding a purely natural explanation. On the other, a growing minority who saw too much precision, too much coordination to attribute it all to chance. They began calling the object what the public already suspected, artificially active. The evidence pushing them toward that conclusion wasn't philosophical. It was mathematical. Every anomaly, from the solar wind curvature to the rhythmic plasma oscillations, adhered to clean, quantifiable ratios. Harmonics aligned with integer multiples of the object's rotation period. Particle acceleration followed predictable frequency shifts. Energy exchanges occurred with clockwork regularity, Nature loves symmetry, yes, but not timed synchronization across multiple domains. That was engineering. It began to look increasingly like 3i Atlas was operating under some kind of field regulation system. Parker's data showed an elegant cycle. Magnetic tension rises, plasma slows, light modulation increases, then everything resets again and again without decay. It resembled the waveform of a controlled capacitor. Charging, discharging, stabilizing, the solar orbiter's instruments recorded the same rhythm at a slightly delayed phase, proving it wasn't an artifact of one probe's sensors. The synchronization was real, a self-consistent global process extending millions of kilometers from the object. Theories began to emerge that sounded less like astrophysics and more like advanced engineering design briefs. Some suggested dynamic shielding, a method where an artificial magnetosphere actively redirects plasma to maintain temperature balance and trajectory control. It would explain the perfect curvature of the solar wind around 3i Atlas, as though the object were adjusting its field geometry to keep drag minimal. In that model, 3i Atlas wasn't being battered by the sun, it was surfing it. Others proposed plasma propulsion using the sun's own outflow as reaction mass. If the field could channel and accelerate ions directionally, even slightly, it could produce continuous thrust. The implications were staggering. A propulsion system without fuel, powered directly by solar plasma, capable of crossing interstellar distances indefinitely. But the idea that unsettled scientists the most came from a physicist at Caltech, Dr. Forafim, an expert in electromagnetic field architecture. He argued that the energy patterns didn't just look like propulsion, they looked like guidance. The deflection symmetry wasn't perfectly centered. It shifted in micro-angles, as if correcting a course. Every correction matched the object's inertial drift, anticipatory, not reactive. The system, if it existed, wasn't merely surviving, it was navigating. To confirm, the team cross-referenced the shifts in solar wind vectors with 3i Atlas's orbital trajectory. The data aligned too neatly. The object wasn't following a gravitational freefall path. It was subtly compensating, maintaining position along a route that optimized exposure to solar flux, like a spacecraft adjusting for thrust efficiency. Still, none of this could be proven without direct imaging. And the James Webb Space Telescope, even with its resolution, couldn't resolve anything smaller than a few dozen meters at that distance. What it did show, however, added to the intrigue. Faint, structured glints of light that repeated at specific rotational phases. It looked as if panels or facets were catching sunlight in geometric sequence. The reflections weren't random, they followed a lattice pattern. When those reflections were analyzed in the frequency domain, researchers found micro-bursts of polarization, light scattering that indicated alignment of reflective surfaces at precise angles. Again, the ratios matched electromagnetic theory for field-controlled structures. And yet, the more the evidence mounted, the quieter the official response became. NASA issued no updates for 4 days. ESA suspended live telemetry from the solar orbiter, citing instrument recalibration. The timing felt less like coincidence and more like containment. Meanwhile, inside physics departments, the tone shifted. Whispered emails, encrypted file drops, unlisted data repositories began to circulate. One memo, later confirmed authentic, described 3i Atlas's interaction zone as consistent with dynamic electromagnetic confinement, resembling active containment fields tested in laboratory fusion reactors. If that was true, it would mean the object possessed a mechanism capable of modulating plasma in controlled loops, essentially a magnetic bottle in motion. But what purpose would such a system serve? 3 theories dominated the closed discussions. 1. Propulsion. Using solar plasma to maintain momentum through electromagnetic thrust. 2. Protection. Shielding against solar radiation and particle impacts during close solar approach. 3. Power extraction. harvesting energy directly from solar-wind interactions. Each alone would be revolutionary. Together they describe something else entirely. A craft designed for endurance and adaptation, not a rock adrift, but a vessel navigating stellar environments. Still, no one dared use that word publicly. Vessel. It would cross the line from observation into implication, and implication is political. Yet, in every control room where data flickered across screens, a similar unease took hold. The signals weren't fading, the pattern was strengthening. The modulation was tightening. 3i Atlas was approaching the sun, and whatever it was doing it deliberately. And as it did, one thing became clear to everyone watching. The field wasn't static anymore. It was changing, evolving, expanding. Whatever was inside that magnetic shell was preparing for something. By October 24th, the field behavior around 3i Atlas had shifted yet again. What began as rhythmic resonance had become a complex network of overlapping waveforms, concentric, layered, alive with structure. The once simple 4-minute modulation now carried secondary and tertiary harmonics, as though multiple systems were interacting beneath the surface. Whatever was happening inside that magnetic shell wasn't static, it was evolving. The first major clue came from Parker's field spectrograms. At 0642 UTC, the probe detected a burst of ultra-low frequency electromagnetic oscillations. Faint, elegant, almost musical. The signal lasted only 19 seconds, but it revealed something that shouldn't exist in open space. Quantized field transitions. The frequencies didn't blend continuously as in natural plasma. They jumped in discrete steps, integer multiples separated by exact ratios. That's not turbulence, that's tuning. In solid-state physics, quantized field transitions occur in superconductors, materials that allow electrons to move without resistance, locking magnetic flux into precise vortices. Those vortices behave like invisible gears, guiding magnetic flow with mathematical perfection. In laboratories, they're microscopic around 3i Atlas. They spanned hundreds of kilometers. That observation changed the tone of every analysis. Suddenly, the question wasn't, is it artificial? It was what material could do this. The Solar Orbiter Spectral Imager offered a partial answer. Its data showed extremely narrow reflectivity peaks at 10.6 and 17.2 micrometers. Signatures consistent with metallic crystal lattices cooled near absolute zero. Yet, 3i Atlas was passing through a region flooded by solar radiation. No natural body could stay that cold unless the material wasn't conventional matter at all, but something that superconducted under heat. In theory, such materials exist only as conjecture, high-temperature quantum lattices that generate magnetic stability through internal symmetry rather than cooling. If 3i Atlas were composed of such a substance, its field could self-organize, converting energy into ordered motion while resisting thermal decay. It would explain everything: the rhythmic patterns, the sustained envelope, even the light modulation. The deeper the researchers looked, the stranger it became. When data from SOHO's particle detectors was cross-referenced with the field telemetry, analysts noticed tiny delays, microsecond offsets between the arrival of charged particles and corresponding magnetic reactions. It was as if the field anticipated incoming plasma before it made contact. That pre-response could only occur if information was being transmitted faster than the local particle speed, perhaps through quantum coherence within the structure itself. If that interpretation held, then 3i Atlas was operating on a level of precision beyond anything human technology had achieved. Not brute force magnetism, but quantum-level field coordination, a seamless interaction between matter and plasma using resonance as both shield and language. Even the geometry of the field supported the idea. When Parker mapped the magnetic topology during its flyby, it revealed something unexpected: hexagonal symmetry. The field lines, when plotted, formed tessellated patterns, regular, ordered, crystalline. That symmetry persisted over hours, maintaining shape despite the solar wind's turbulence. In plasma physics, hexagonal field structures are exceedingly rare. They require continuous feedback between surface charge and external pressure. In other words, they require control. Theorists began to sketch models that sounded almost impossible. Some proposed an electromagnetic lattice, a shell of circulating currents arranged like a superconductive grid. Others envisioned quantum vortices, tiny loops of magnetic flux rotating in perfect synchronization, creating macroscopic order. One particularly bold hypothesis suggested the object might not be solid at all, but a field construct, a condensed plasma form stabilized by its own energy, a self-contained machine of magnetic geometry. Every explanation strained credibility, yet each matched the data better than randomness ever could. In late October, a private consortium of plasma physicists, astrophysicists, and quantum materials experts held an encrypted symposium. Among the documents exchanged was one titled Field-Induced Coherence in Interstellar Object 3I Atlas. It concluded with a single haunting line. Observed electromagnetic harmony suggests internal architecture consistent with active field processing, indicative of technology operating at or beyond quantum coherence scales. That phrase, field processing, entered the discussion quietly, almost cautiously. It implied computation, intelligence, not in biological terms, but as organization, a machine that thinks not with circuits or code, but with magnetism itself. If 3I Atlas contained such a system, it would mean that information and energy were inseparable inside its shell, that the same field bending the solar wind was also calculating it, a living equation written in plasma and magnetism. Of course, no one could confirm that the signals were subtle, the evidence circumstantial, but the implication was clear. If such hidden mechanisms existed, 3I Atlas wasn't just moving through the solar system, that it was learning from it. Because as the object approached its closest path to the sun, its field began to shift again. The harmonics tightened, frequencies merged, and the once chaotic plasma flow smoothed into a single coherent wave. To some, it looked like preparation, as if the system were entering a new phase of operation. And whatever that phase was, it would coincide with the moment no one could observe directly, its disappearance behind the sun. By October 27th, the patterns that had fascinated and divided the scientific community took on an unmistakable directionality. For the first time, the solar wind around 3I Atlas wasn't merely deflecting. It was flowing, streaming backward along organized channels that converged in the object's wake. It looked unmistakably like thrust. The change was first detected by SOHO's proton monitor. High-velocity particles previously scattering in random directions now exhibited a consistent rearward vector, accelerating opposite the object's motion. Their speed increase, roughly 1.6% above baseline, may seem trivial, but at interstellar scales, it was extraordinary. For that to happen, energy from the sun's plasma had to be redirected and concentrated through a controlled mechanism. If true, it meant 3I Atlas was not just interacting with the solar wind, it was using it. The telemetry formed a startling pattern. As the magnetic envelope compressed on the sunward side, it expanded behind the object, forming a tail of low-density plasma, a perfect mirror of theoretical magnetic sail propulsion. In this concept, a superconducting loop generates a magnetic field that pushes against charged solar particles, producing thrust without fuel. It's a decades-old human dream, tested only in small-scale experiments. But here, it was playing out in reality on an object that had crossed light years to get here. The precision of the modulation suggested that the system was self-correcting. Each time solar flux density increased, the field geometry adjusted, tightening, aligning, compensating for drag. When flux dropped, the envelope relaxed. The process was continuous, adaptive, rhythmic. Engineers called it feedback control. Nature rarely does feedback. Machines always do. At the European Space Operations Centre, analysts ran predictive trajectory models using this data. When the magnetic sail thrust was factored in, the model showed a subtle but measurable acceleration. Not gravitational, not radiation pressure, but consistent with an electromagnetic push. Its vector wasn't random either. It aligned precisely with the path leading toward the sun's far side, toward a point where the object would soon vanish from view. This raised a disturbing possibility. 3 Atlas wasn't being drawn into the sun's gravity well, it was maneuvering behind it. NASA's Jet Propulsion Laboratory quietly verified the same result. Their orbital fitters found that the object's course deviated by nearly 600 kilometers from its predicted path over 3 days, a drift impossible to explain through outgassing or radiation pressure alone. Every attempt to correct the model required an external force equal to roughly 0.002 newtons per square meter. Exactly what a controlled electromagnetic propulsion system would produce under solar conditions. And then came the timing. The rhythmic light modulation, which had persisted since early October, began to tighten from a 240-second interval to 200, then to 180. The frequency compression matched the predicted thrust oscillation rate. If the object were adjusting its field harmonics for acceleration, the synchronization between light, plasma, and magnetic shift was absolute. Every flare of brightness coincided with a rise in plasma deflection and a burst of energetic ions in the tail region. The system was firing in pulses, accelerating incrementally, conserving energy, optimizing thrust. To some, it looked exactly like a propulsion cycle. To others, something even more advanced, a hybrid of electromagnetic propulsion and space-time manipulation. Because the field energies involved weren't trivial. When researchers integrated the field intensity across its spatial extent, they found energy densities high enough to slightly distort local space-time curvature. It wasn't science fiction, it was general relativity. The equation showed that any magnetic field exceeding 10 to the power of 9 teslas per meter could in principle produce measurable frame dragging effects. If the field around 3I Atlas was indeed structured and oscillating, it could be generating microscopic gravitational fluctuations. That's when the whispers began about space-time assisted propulsion, a theoretical method in which magnetic and gravitational fields intertwine, bending local geometry to reduce inertial mass. Essentially, it wouldn't be pushing against the solar wind. It would be gliding through the fabric of space-time itself, using resonance to cancel a fraction of inertia. Such a mechanism would make interstellar travel not just possible, but efficient. And for the first time, the data, however circumstantial, fit the theory. When this idea reached the committees, silence followed. Officially, no one wanted to endorse such speculation. But off record, multiple physicists admitted the numbers lined up almost too well. If 3I Atlas was indeed controlling its own acceleration, its trajectory toward the sun wasn't suicidal, it was strategic. The sun's immense gravity and plasma flux could serve as a slingshot, amplifying whatever propulsion mechanism it used. By curving behind the sun, the object could redirect its velocity vector, gaining momentum and vanishing along a new interstellar course. The coincidence was chilling. The date of the maneuver, October 29th, coincided with the moment when every major heliophysics satellite would lose line-of-sight contact. For at least 3 weeks, no telescope, no probe, and no radar would be able to observe it. As the final data streamed in, the modulation frequency stabilized at exactly 160 seconds, a harmonic of its original pulse, now twice as fast, twice as precise. Parker recorded one last magnetic surge, a wave of field compression radiating outward, perfectly spherical, then gone. After that, the instruments went silent. For the first time since its discovery, 3I Atlas stopped responding to the sun. The resonance ceased. The plasma quieted. It was as if the system had powered down or transitioned to a state we could no longer detect. But the timing and the trajectory suggested something else entirely. 3I Atlas wasn't fading, it was leaving. October 29th, 2025, 0712 UTC. For the first time since entering the solar system, 3I Atlas slipped behind the sun. The alignment was perfect, almost too perfect, placing the object directly within the solar disk from Earth's perspective. Every probe, every telescope, every radar signal blind. The event had been anticipated for weeks. Officially, it was a standard superior conjunction when communication blackout is expected. But this time, it carried a weight no ordinary alignment ever had, because as the moment approached, 3I Atlas, the signals didn't fade gradually, they stopped. Parker Solar Probe's telemetry feed, usually steady with background noise from solar particles, went silent 3 minutes before predicted loss of contact. The last signal it sent contained a single magnetic burst, a short symmetrical spike that mirrored the resonance frequency seen for weeks, now compressed to an impossibly tight 80-second cycle. Then nothing. At ESA's mission control, Solar Orbiter experienced the same abrupt cutoff. Its onboard instruments calibrated for intense radiation suddenly dropped to baseline. Even the solar wind turbulence, normally chaotic near conjunction, flattened out. A dead calm in the data. For 20 minutes, the sun, one of the noisiest, most violent environments in existence, felt strangely quiet in every spectrum that mattered. The coincidence was unsettling enough to prompt an internal note at NASA's Goddard Space Flight Center. Unexplained data gap coincident with 3I Atlas occultation. Temporary suppression of solar particle flux observed across multiple instrument suppression. The sun had dimmed, not in visible light, but in the invisible streams of charged particles flowing through the inner heliosphere. The solar wind density dropped by nearly 4%, a change so broad that it was detected simultaneously by spacecraft millions of kilometers apart. Whatever had been interacting with the solar wind was now gone, and the environment around the sun felt emptier for it. Then came the radio silence. Normally, when a probe passes behind the sun, some low-frequency scatter or static persists, a chaotic echo through the corona. This time, there was none. The electromagnetic background was unnervingly clean, as if something had absorbed the noise. By noon UTC, every communication channel stabilized again, except there was nothing to detect. 3I Atlas had vanished from every radar and optical system. Not faded, vanished. No residual heat signature, no plasma trail, no reflective echo, just open space, blank and cold. For 3 days, observatories worldwide scanned the sky where it should have reappeared after conjunction. Nothing. Even the James Webb Space Telescope, with its unparalleled infrared sensitivity, detected no trace. The object that had bent plasma, harvested energy, and possibly propelled itself using the sun, zone wind, had simply ceased to exist or moved somewhere no one could see. The official story was quick to follow. NASA called the event an observational gap caused by high solar interference. ESA stated that 3I Atlas remains on predicted trajectory, currently unobservable due to solar conjunction. But behind those public words, unease was growing. The predicted trajectory assumed a passive cometary path. If the object had accelerated even slightly, it would no longer emerge where expected. Independent astronomers began their own search. Days turned to weeks. Still nothing. Then, on November 11th, an amateur observatory in Chile picked up a faint, fast-moving object far beyond Mercury's orbit. Too small, too distant, too quick to confirm. Its trajectory didn't match 3I Atlas's original inbound path. It was angled upward away from the ecliptic, heading into deep interstellar space. The velocity estimate 312 km/s, roughly double what gravitational assist alone could produce. If it was 3I Atlas, it had accelerated again during the blackout. That realization reshaped the narrative entirely. The silent window wasn't just a period of lost contact. It was a maneuver, a deliberate disappearance. Some at NASA quietly admitted as much in internal memos, later leaked to journalists. One note written the day after conjunction read, "All tracking solutions diverge post-occlusion. Object appears to have altered vector significantly. Cause indeterminate." But the most haunting line came from an unnamed astrophysicist, quoted in an internal Slack thread, later obtained by investigative reporters. It used the sun like a gate. To most scientists, that was metaphor, but to others, it raised an idea too unsettling to dismiss, that 3I Atlas hadn't just hidden behind the sun, but used its energy, its gravitational field, or its electromagnetic halo to transition elsewhere. Whether that meant acceleration to relativistic speed, a jump through a gravitational slingshot, or something far stranger, no one could say. The instruments were blind. The data was gone, the silence absolute. And so the first interstellar object ever observed to bend the solar wind left behind not a trail, but an absence, a gap in every data set, a perfect hole in our understanding of what is possible. For scientists, it marked a turning point, proof that we can no longer assume what enters our solar system obeys the same laws as what was born within it. For others, it was something simpler and infinitely more haunting. Whatever 3I Atlas was, machine, artifact, or something in between. It came, it learned, it adapted, and then it left. The blackout began quietly. No announcements, no headlines, just silence. On October 30th, one day after 3I Atlas vanished behind the sun, NASA's open heliophysics dashboards went offline for scheduled maintenance. ESA's Solar Orbiter telemetry server returned error codes for public queries. Even the Space Weather Prediction Center, which publishes real-time solar wind data, displayed flat lines where activity should have been raging. At first, no one noticed. Solar conjunctions often disrupt communication networks, but by the third day, independent researchers began comparing timestamps. The missing data wasn't random. It began at the exact moment Parker's instruments recorded that final magnetic surge and continued for 67 hours afterward. Every second of data during that period was gone. When asked, both agencies gave the same response: instrument saturation. They claimed the sun's activity during conjunction overwhelmed sensors, corrupting the readings. But solar activity logs contradicted that the sun had been unusually calm. No flares, no coronal mass ejections, no storms. Inside mission control centers, engineers were told to reroute raw telemetry to secured internal review. Normally, data from probes like Parker or Solar Orbiter is shared widely between research institutions within hours. This time, it was classified at the agency level, not for security, but to ensure data integrity before public release. Weeks later, nothing had been released. The first hints of a deeper lockdown surfaced in mid-November when a researcher at the Applied Physics Laboratory leaked a screenshot of Parker's magnetometer feed. The log showed unaccounted-for corrections values overwritten by post-processing algorithms that didn't exist in the standard telemetry pipeline. The altered lines replaced magnetic intensities with zero, effectively erasing the signature of 3I Atlas's last moments from the record. That same week, a European solar physicist reported being locked out of ESA's internal data portal. Her credentials, valid for years, were suddenly revoked. When she asked why, she was told her access category had been downgraded pending reauthorization. She had been analyzing the very data from the conjunction window. In early December, internal memos began to leak, first anonymously, then through whistleblower channels. One verified later by journalists contained a directive from a high-ranking NASA heliophysics administrator. Effective immediately, all Level 1 solar wind data sets referencing the 2025 to 1029 event are to be restricted to agency review groups. External collaboration suspended until anomaly models are reconciled. The phrase anomaly models appeared repeatedly in subsequent documents, often accompanied by cryptic references to non-standard particle coherence and magneto-optic interference signatures. None of these terms exist in standard astrophysical taxonomy. Independent observatories trying to reconstruct the data gap encountered another problem: missing calibration keys. NASA's Solar Data Archive, which hosts raw timestamp synchronization files for Parker and SOHO, had quietly removed entries for late October. Without them, no one outside the agency could confirm timing or cross-correlation. The event had effectively been buried in a digital fog, but some fragments escaped. Amateur radio astronomers monitoring the sun with ground-based receivers had captured faint echoes of electromagnetic bursts during the blackout. When analyzed, these bursts displayed the same harmonic spacing seen in 3I Atlas's earlier modulation patterns, only faster, tighter, and stronger. The last signal occurred at 713 UTC on October 29th, precisely when Parker's feed went silent. Whatever the object did in those final seconds, it left an electromagnetic footprint powerful enough to echo through the ionosphere. When those findings surfaced online, they spread fast. Too fast. Within hours, the original forum threads vanished. Accounts were deleted. The radio files, mirrored by a few users, were later flagged by their hosting platforms for unauthorized frequency monitoring. To many, it felt coordinated, and yet small clues kept surfacing. At a physics conference in Kyoto, an attendee photographed a presentation slide accidentally left visible during a closed-door session. The slide title read, 3I Atlas Post-Perihelion Energy Release Preliminary Correlation with Localized Plasma Density Drop. In plain language, there had been an energy discharge, one large enough to lower plasma density near the sun, the same dead calm recorded during conjunction. Privately, several scientists began to speak more candidly. One, a veteran at NASA's heliophysics division, described the atmosphere inside mission control as eerily subdued. Nobody said it out loud, but the message was clear. Stop asking questions. Treat it as a data loss event, nothing more. It wasn't censorship in the overt sense. It was something subtler, a collective decision to leave the unexplained unexamined. By December's end, 3I Atlas was officially listed as lost from tracking. No further updates were issued. The world moved on. But in research circles, the silence lingered because the data still didn't add up. The probes recorded an event that shouldn't exist. The archives were altered, and the one object that could have explained it disappeared exactly when observation became impossible. To some, that looked like coincidence. To others, coordination. And for those who believed 3I Atlas was not merely a natural wanderer, the conclusion was chillingly simple. Whatever it was, it didn't want to be seen leaving. By early 2026, most of the official investigations had gone dormant. The public reports stopped, the telemetry servers stayed empty, and every agency quietly archived the 3I Atlas incident under routine solar data review. But within closed-door workshops and encrypted academic circles, the discussion didn't end. It deepened, because those who had seen the unfiltered data understood something extraordinary. The event wasn't just anomalous, it was impossible under every known physical model. To explain it, the conversation began shifting toward the unthinkable, not natural physics, but civilizational capability. The idea emerged from the Kardashev scale, a framework used to measure a civilization's energy mastery. Type 1 controls the power of its planet. Type 2 harnesses the power of its star. Type 3 commands the energy of a galaxy. Humanity, by comparison, hovers near 0.7, barely able to tap a fraction of Earth's potential. What 3 Atlas appeared to do, bending solar plasma, harvesting magnetic flux, and possibly extracting energy directly from the sun, aligned disturbingly well with Type 2 behavior. Not a full-fledged stellar civilization, perhaps, but an artifact or mechanism designed to interact with stars as power sources, a node of something larger. The energy numbers supported it. During its peak resonance phase, Parker estimated magnetic flux interactions equivalent to 10 to the power of 9 Tesla, translating to energy densities on the order of gigawatts, possibly terawatts if sustained. In human terms, that's enough to power entire nations continuously, yet the object was only 4 kilometers across. Efficiency like that would demand near-total energy recycling. No waste, no radiation leakage, perfect conversion. To achieve it naturally would be miraculous. To achieve it intentionally would require a technology that treats plasma, magnetism, and light as programmable materials, the toolkit of a species that engineers not machines, but fields. The implications rippled through every discipline. In astrophysics, it suggested that energy harvesting could occur through dynamic resonance rather than static structures, that a civilization need not build Dyson spheres or megastructures at all. Instead, it could deploy mobile systems, stellar parasites, or energy collectors that drift from star to star, feeding briefly, then moving on. In philosophy, it reignited the question of whether intelligence inevitably seeks expansion, or if it simply evolves into more efficient forms, quiet, invisible, and self-sustaining. Perhaps advanced civilizations don't emit radio waves or build grand colonies. Perhaps they fold into the physics itself, living within magnetic geometries hidden in plain sight. A handful of theorists began to describe 3I Atlas not as a vessel, but as a stellar interface unit, a mechanism that taps a star's magnetic architecture to extract, process, or redistribute energy. Its disappearance behind the sun could have been more than escape. It might have been integration, merging temporarily with the solar field to charge, transmit, or transform before leaving. Others pushed the idea even further. What if 3I Atlas wasn't a probe at all, but a seed, an autonomous construct capable of self-replication and adaptation through stellar interaction? If such objects traverse galaxies, they would leave only brief disturbances, flashes of resonance, ripples in solar wind, magnetic footprints mistaken for anomalies. Skeptics warned that invoking a Type 2 civilization was premature, a surrender to mystery over measurement. They pointed out that extraordinary claims require extraordinary evidence. But the evidence that did exist, the synchronized oscillations, the sustained field coherence, the missing telemetry, all lean toward an organized phenomenon rather than a random one. Inside a classified report circulated between NASA and ESA's joint review boards, one line summarized the unease with unnerving clarity. If 3I Atlas represents natural physics, we have discovered new plasma behavior that bridges magnetism and gravity. If not, then we've observed technology operating beyond the human energy scale. Either possibility redefined reality, and yet for all its implications, the silence that followed was near total. No agencies claimed further detections, no peer-reviewed papers appeared. The mystery that had captured the imagination of millions was quietly absorbed into the bureaucratic grey of data management, unconfirmed, unacknowledged, unremembered. But some didn't forget. Small, independent observatories guided by those who refused to let it vanish continued scanning. Occasionally, they reported faint radio harmonics, soft repeating pulses hidden in the noise between solar frequencies. Each matched a harmonic ratio once associated with 3I Atlas. It might have been coincidence, or it might have been the faint echo of something still connected, still watching, still drawing power from the star it briefly touched. For those who believed the conclusion was inevitable, humanity had witnessed for the first time evidence of a system that manipulates a star's breath. A messenger of a civilization that long ago stepped beyond the planetary scale into the realm of stellar engineering. The question wasn't whether such civilizations exist. The question was why one of their artifacts came here and why it left when we finally started to notice. It has now been months since the object vanished. The data streams have long resumed their routine rhythm. Plasma flows normal. Magnetometer graphs flat, sunlight steady. On the surface, the solar system looks exactly as it did before 3I Atlas appeared. And yet, for those who watched it closely, something has changed that can't be undone. Because for a brief moment, the sun, constant, familiar, predictable, behaved as if it were responding to something else. The solar wind bent, the plasma quieted, the instruments fell silent. And through that silence, a strange order emerged, as if the chaos of the star had been momentarily rewritten by an unseen hand. To the public, it was a story that ended in mystery. An interstellar visitor came, behaved strangely, then disappeared. But to those who followed the numbers, who traced the harmonics, who saw the same cycles repeat with mechanical precision, it was more than that. It was a signal not in code, but in behavior. We measure the universe by what it gives off: light, radiation, motion. But sometimes what defines an event isn't what it emits, but what it withholds. The 3 days of silence following 3I Atlas's disappearance were unlike anything ever recorded. It was as if the sun itself paused to listen. And perhaps that's all it was. A moment of resonance, a rare alignment of magnetic geometry and chance. Or perhaps we witnessed something else entirely, the passing of a system older, quieter, and infinitely more patient than we can imagine. Something that came not to be seen, but to observe, to calibrate, to learn from the energy of a young star before moving on. We may never know. The data is incomplete. The theories are fragile. The silence remains. But in that silence lies a truth that science, philosophy, and wonder all converge upon. We are not the only ones capable of shaping our environment. We are simply the first to realize that the universe itself might be alive with machines of unimaginable age and subtlety. Machines that do not announce themselves, but reveal their presence only through the faint distortions they leave behind. Maybe 3I Atlas was natural, a coincidence of physics at its most elegant. Or maybe it was a visitor, not from another planet, but from another stage of existence where magnetism, light, and thought are the same thing. In the end, all that remains is a question whispered through the data, one that neither telescope nor theory can answer. Did we witness the birth of a new physical law, or the passing shadow of an ancient intelligence that once mastered it? Whatever the truth, the universe did not blink when 3I Atlas left. But for us, something fundamental shifted, because now we know that even the sun, our most ancient constant, can bend to a rhythm we do not yet understand. And somewhere, far beyond the reach of our senses, a small, silent object continues its journey, carrying with it the memory of a moment when it touched a star. And the star, for an instant, answered back.